Right. So what we're ready now for is to start talking about React. But just before I do that, let's just go into that car there. There are two labs with this section. To be honest now, I don't think we're going to get far enough in today's lecture to be able to tackle either of these labs, but that's okay. I have something else set up for this week's labs. But before I start into the slides in this section, I just want to go back for 1 second. Probably fairly obvious what I'm going to mention, but if we go back to that stuff we were doing on functions and using the random user API, if I go into here, just 1 sec. So I'll start my Go Live server as usual and open up my developer tools. So the script that I'm running now is this one here. Now, at the very bottom, I've put a console.log of the end. But if we look at what's actually outputted to the browser's console, that very last log message appears at the very beginning. Anybody want to hazard a guess as to why is that? So the answer is we've got asynchronous code going on here. There's two types of code that you might write, synchronous and asynchronous. The majority of what you have written up to now, I imagine anyway, is synchronous code. And the nice thing about synchronous code is that the statements in your program execute in the order in which they kind of physically appear in your source code file. That's not the case though with asynchronous code. And being specific to this example here, we know that, for example, this here, none of that is going to execute until we get the response, the full response back from the random user API. But that happens sometime kind of in the future, as we say. It doesn't happen immediately. And equally, you know, this statement here doesn't execute until the beginning of the response from the random user API comes to the browser. Like if I stuck a console.log in here, that console.log, yes, it would appear before this console.log here, but it would not appear before this console.log down here. This last console.log is always going to execute first. Because the way it works is the fetch, okay, the fetch executes, but it's then waiting for the response to come back. But the browser doesn't hang around waiting for the response. It essentially kind of jumps over all of this code and continues executing from here on. Eventually the response comes back, then it jumps back to here and starts executing that. And when all of the response has come back from the random user API, only then does it execute this. So that's just the nature of asynchronous code. So you've got to be careful where you put your code. If you want code that's going to be using the data that comes back from the API, you've got to put it in here. You cannot put it down here, because any code you put down here is going to execute before the data comes back from the API. That's the first point. And the second point is, in the previous lecture, we talked about the browser being an event-driven environment. Now, even though it's not obvious here, I think I mentioned this in the video anyway, it's not obvious here, but there is actually event handling going on here. What we would say is that essentially this callback is an event handler for the event associated with the full response having arrived back at the browser. And similarly, this code here, this entire callback function is actually an event handler for the event associated with the beginning of the response coming back from the API. The browser takes care of relating this callback to the relevant events and this callback to the other event. It takes care of doing that for you, but it's not so much the browser does it, but internally within the then function, these then functions, they take care of that. But there is event handling going on behind the scenes in all of this code as well. But the main point I wanted to make was this idea of asynchronous and synchronous code. That's number one. And number two, like the browser does not wait around until the response comes back before it decides to do anything. It will try and execute any code that you have down here immediately. And eventually when the date comes, then it jumps back to executing this code up here. Okay, that's all I wanted to just make sure you were clear on, because those kind of issues that will arise later on, because you will be writing asynchronous code both in the browser and on the server side. So back to here, and we now need to start looking at React. There's an archive with this set of slides. As with most of my archives, you just click on the link, you download it. In some cases, you may need to do a small installation, but I'll talk about that in a minute. So let's start our discussion on React. Just do a quick bit of background on the framework. Then we'll talk about the fact that React is focused on the V part of MVC. You may remember coming across MVC. It's one of these design patterns. You would have used it in the context of Web App Development 1. But I'll come on to that in a moment anyway. But then we'll talk about something called JSX, which is it's a syntax that is an extension of JavaScript. And it's really this JSX syntax that's kind of one of React's kind of sweet spots, even though lots of other frameworks use it now. And it's what really made React so popular initially. But because of that popularity, many other frameworks have actually piggybacked on this JSX syntax. JSX was not created by the React team. It was a separate technology, but the React team adopted it. Then I'll talk about one or two, well, there's two developer tools that we will be using throughout this module. One we'll use at the beginning, and then the other one we'll use for the entire discussion on front-end development. And finally, then we'll talk about one of the key constructs of a React application, which is this notion of a component and how we code components and some of the fundamentals of components. So as if we don't know by now, what is React? It's something, it's a JavaScript framework for building dynamic web user interfaces. By dynamic, we mean the user can interact with the user, with the user interface, and the interface changes or may change as a result of that reaction. That's what we mean by dynamic. Of course, we now know this term single page app, so we could say that React is a single page app framework. It kind of means vaguely in it, that means something. That's how we would categorize it. React actually began life as an in-house project in Instagram. This is before Instagram was acquired by Facebook. Lots of software tools and frameworks and platforms begin life as in-house projects. And then the organization that actually developed those in-house projects open sourced them, which is where we can gain access to them. So I'm not sure what it was called what the project was called within Instagram at the time. This is pre-2012 now. I don't know when it began really. And it may well have been a special purpose piece of technology. But eventually, anyway, Facebook, as we know, acquired Instagram. They liked this particular piece of software that was being developed within Instagram. As I said, it may well back then have been a special purpose application, but they abstracted from it a framework. And then fortunately for us, they open sourced that framework. And that was open sourced, I'm saying, around 2012. So that's how the general community are able to use it freely. There's kind of nerdy discussions as to whether React is a framework or a library. We needn't worry about it. You can call it whatever you want to, but either way, it's a client-side piece of software. And more technically, we would say it's a single-page app technology. Now, React was not the first single-page app framework available to the community. There were many others at the time, back in 2012. But what distinguished React from all of the other ones that existed at the time was that React did not follow this MVC pattern. MVC stands for Model View Controller, as you might remember. And essentially, it's a pattern that helps you to structure your code, right? You kind of structure your code into model parts and V parts and view parts and controller parts. But the React team, engineering team, decided that they were not going to follow that, that they were just going to focus in on the V part of MVC, where V stands for view, which is why we say that React is a user interface. It's only concerned with the user interface. It's not concerned with business logic or modeling the data model part of your application. Even though the data model is very important, it doesn't give us any, there are no aspects to React that help us with that. We tend to use either third-party libraries. So it's much more focused anyway, or at least it was back in 2012. So it's only concerned with the V part of MVC. And in this slide, really, one of the points I'm making is that React deviated from what was normal kind of best practice at the time, but it turns out that those deviations seem to have been successful because the framework is now by far and away the most popular single-page app framework. So one deviation is that didn't follow MVC, just focused on V. Also back around 2012, most of its competing single-page app frameworks used a technique called templating for actually coding up the V part, the view part of your application. You may have come across templating in Web App Development 1, even though that might be a few years back now for some of you. You may have used something called handlebars. I'm not certain. There are a number of templating technologies out there. But the long and short of it is React did not use templating either. They decided they were going to base the structure of your React app around the notion of components. Component was a kind of a novel idea back then. A lot of single-page app frameworks today follow this component idea. And we'll see what I mean by components in a while. So kind of the upshot of some of those design decisions that the React team made, I'm just documenting them in this table here. I wouldn't worry too much about it. They argue that the reason they went for the component model as opposed to the templating model was you achieved better separation of concerns in your overall code. You know, the templating model, okay, there was separation of concerns, but it was somewhat artificial in that you wrote all your view part in HTML files, and you wrote all your other dynamic aspects of your application in JavaScript. Okay, there were physically different files, but it was somewhat artificial. Whereas you will see with React components, a component has both a HTML and JSS and JavaScript, sorry, mixed into the one physical file. But you still achieve better separation concerns on a responsibilities kind of criteria. Let's not worry too much about it. From a semantics point of view, the React team said, well, we're only going to be using HTML and JS, and they are very well-founded languages, and people understand them. Whereas with the templating approach, you essentially had to learn a new syntax, and the semantics of it would not be as powerful as HTML and JS. Expressiveness is kind of along the same lines. The templating syntax that you had to learn would not be as powerful as something as mature as JavaScript and HTML. And really, as I said, React only used those two core technologies. So React is all about building components, as we'll see, rather than building templates. And I've already kind of alluded to the fact that React is completely focused on the user interface of your application. So it doesn't concern itself with business logic. It does not concern itself with the data model, as I said. The data model is really the M part of MVC. Now, that has kind of changed in the intervening years, and more recently, the M part, we do actually, React does support the M part of MVC. But we'll see that much later on. I don't want to get bogged down in it really at this stage now. So if you think this is a tiny bit abstract, then that's okay. So a component, I'm saying, is the unit of composition for a React app. And this is important now. I'm saying a component has two parts to it. It has the UI description part and the UI behavior part. The UI description, we implement that in HTML, which we're very familiar with. The UI behavior we implement in JavaScript. By behavior, I mean, how does the user interface change or behave as a result of the user interacting with the page? Okay, so we're going to express that behavior in JavaScript, which makes sense. Now, I've also kind of alluded to the fact, okay, these are the two parts that make up a component, HTML and JavaScript, but these two technologies can actually be co-located in the same file. And that's what was unique about React at the time. So they're actually co-located, or they're tightly coupled together. And the React team would argue it is logical that they should be tightly coupled. Obviously, the behavior and the description should be very closely linked to one another. You shouldn't have to go jumping from one file to the other when you're doing your editing of a particular component. And arguably then these are the benefits from this kind of approach that they took. So a component has two parts, the UI description and the UI behavior. We won't get any further than talking about the UI description in this set of slides. We'll add in behavior a little further down the line. Now, the React framework comes in two different, it's spread across two different packages or libraries. One is called React and the other is called React DOM, but they're just two physically different libraries. And when you boil it down, the React library provides one method called createElement, and that method will create a HTML element. You've got to give it some arguments, but we'll see what they are in a second. But that's essentially all it does. It creates a HTML element, or based on what I was talking about the last day, it creates a DOM element. It doesn't attach the element to the DOM though, it just creates it. The React DOM package, it also essentially only has one method called render. And what the render method does is it allows you to attach an element to the DOM. So the two together now essentially are all we need to write any kind of dynamic web page using React. Let's dig a little bit deeper. So the createElement method takes these arguments or parameters. You've got to tell it what type of element you want to create, what properties you want to associate with that element, The main property might be some CSS class that you want to associate with the element, or an event handler. Maybe you want something to happen, some piece of code to run when the user clicks on the element. So that's what we mean by properties. And we know that HTML allows you to nest elements within elements. And so the way you might express that using the create element method is you can specify what children, the element that you're creating, what children does it have? And you can have 0 or more children. Now, we never actually use this method directly. If we had to, then really React would never have caught on. But behind the scenes, it is being used all over the place. And I'll prove that to you in a little while. So the way if we had to use this React.create element, then we would be writing very imperative kind of procedural type code. And that really just isn't any fun. The React DOM.render method, it takes 2 arguments. You've got to give it a reference to the element that you want to have rendered. In other words, have displayed on the screen. And presumably that element was created by the previous method. And secondly, you've got to tell the render method where currently on the DOM do you want to attach that element. So that's pretty straightforward. Now, there's a set of samples that I'm just going to step my way through. These samples are this archive over here. So you download, unzip the archive, and what you will find is, close that, sorry. Just while I'm fiddling around, are there any questions I wonder that arise? No, okay, so this is the contents of this archive. There's just as we can see on the right, there's a bunch of HTML files. And it's the same old story. Well, one slightly different aspect to this little archive now. There's a file here called package.json. Up to now, any JavaScript that we have been writing has not relied on any third-party packages or libraries. But of course, we do, if we want to use React and React DOM, they are third-party packages or libraries. So we need to install them. And you install them locally within the project itself. So every project that you have that uses React and React DOM, the best practice is to install them locally in each project rather than globally. What you do is you create a file called package.json. Invariably, now I will provide you with these files, so you won't need to. It's a JSON file, and this one has very little in it. And you can see from this part here, this is where we state what third-party libraries this JavaScript project is using. So here we go, we're using our React and our React DOM and particular versions of them. When you have a package.json, we want to install those, and the way you install them is you run the command npm install. npm stands for Node Package Manager. It actually was installed when you installed Node itself. And so this command, what it does is it goes looking for package.json locally, and then it finds the dependencies as they're called here. The dependencies are third-party libraries, and it downloads them from a known remote repository and installs them locally in a folder called Node Modules, which you'll see up here on the top right. So if we open up that, in fact, it installs, you see, it turns out that these third-party libraries, they also have dependencies on other third-party libraries. So while I'm only specifying 2 here, there's actually quite a number of third-party libraries installed as a result. And we can get a kind of indication of it here. And there could be anything up to a couple of hundred really in React projects that we'll be working on later on in this module. But for now, anyway, that's where they're installed. And you never need to go near Node modules, really. Don't ever, you can if you want to go poking around there, but you won't ever need to make any kind of edits. So I've installed previously, I've already installed my third-party modules, so I'm good to go. And as before, I am going to be using just the live server. This is probably the last occasion when we will use it. And by the way, when you're using the live server, just make sure you don't have any file open. I should have mentioned that when I talked about live server. So I'm going to click on my live server. And I'm going to step my way through some of these samples. So let's start with the 01. And that's what it displays. Now, let's look at the actual HTML file. So here it is here. And I'm using those two methods that I talked about. Now, again, bear in mind, we are not going to be writing code like this, but there's a purpose as to why I'm doing it here. So for now, anyway, this is a standard HTML file. In the body of the HTML file, there's a div and nothing else. But there is, of course, this script. And it's the script here that's what's generating what we saw in the browser. And so it's using my sorry, now just 1 sec. Oh yeah, you can see here I'm also including the React script and the React and the React DOM script. So I do need those, obviously. And then here's where we come in. So I'm going react.createElement. I'm asking it to create a H1. I'm saying I want to give it these properties. What this here is referring to is a CSS class, which I have defined inside here. Nothing too interesting, really, but that's where it's coming from. And there's probably only, I think, 2 differences between standard HTML and the HTML that you write when you're using React. And one of the differences is you cannot use, when you want to associate a CSS class with a HTML element when you're doing normal HTML development, then the attribute is called class. You can declare an attribute of a HTML element called class, and you assign it the CSS class that you want to have associated with that element. Now, since ES 2015, the word class is a reserved word in JavaScript. And so the React team realized we can't use that now. So that's really what class name means. It refers to, it's indicating that you want to associate a CSS class with, in this case, the H1 element. And that's the name of the class. And you can see that I'm actually pulling in the CSS file up here. But from a React point of view, the net effect of this piece of code is to create a HTML H1 element. Similarly here, I'm creating an LI element. I'm creating an LI element. I'm creating another LI element and a third one. Then I'm creating a UL element. And in this case, okay, it's a UL element. I don't have any properties that I want to associate with it. And it has 3 children. And of course, the 3 children are my LI elements that I've created up here, which kind of makes sense. We want to nest the LI elements inside the UL element. Moving on, I then create a div. I associate a CSS class with that div. And the div has 2 children, the header element that I created at the top and the list element that I created just above it. And finally, I do my React DOM.render, and I tell it I want to attach, I want to attach root element, which is this one here. And what I'm doing over here, this is actually old style DOM API code. This is telling it where on the DOM I want to attach that root element. And I'm specifying, I'm saying, go look for an element with mount point as its ID. And if you look at my div up here, it has that as its ID. So I want to attach it to the div. So the flow is create your elements, and then finally attach the kind of the head of that set of elements that you've created, or sorry, the root, let's say, of those set of elements that you've created, attach that to the DOM, and suddenly it appears. If I take out this line here, okay, and save it, my live server automatically updates the browser, and suddenly there's nothing appearing on the page. So that kind of reinforces what the effect of this line of code is. It's what updates the DOM of the browser. And as we know from the last day, whenever the browser's DOM is updated, then the browser will repaint the screen. So I'll just pause again for a second. As I've kind of said twice already, I think we won't be writing React code like this. This is low-level React code, but any React code we do write is going to be transpiled using the Babel transpiler. It's going to be transpiled down to this stuff. We'll never be editing or debugging this stuff. Hopefully we shouldn't have to anyway. We will be debugging a much cleaner, higher level kind of syntax. But just for now, if there are any questions on that? No? Okay, so we've seen how to create elements using React and how to attach an element to the DOM. That's what those two methods allow us to do. Right. Now, there's only one slight improvement that we could make to this. This is quite long-winded code. And there's one slight improvement we could make, which is, so I've declared header here, and the only place I'm using header is down here. So I could just get rid of that and actually put in the code itself. So just grab all of this. And stick it down here. This is nothing unique to React. No, you could do this with any kind of code that you write. So that now means I can really kind of get rid of this. We don't need this anymore. And assuming I haven't made any syntax error, let's just save it. No, did I do something wrong? Oh, I need to bring this back in, sorry. Okay, so it still works fine. Now we could do the exact same with all of the other elements that we created. Item 1, item 2, item 3, we could just get rid of those lines and in here, put the actual invocation of create element in there for all of them and keep on going. And what we finish up with is this. So we have React.createElement, and I've got kind of nested invocations of React.createElement inside in it. That's kind of, that will come back to help us understand something a little bit later on. But for now, all I've really done is what's called variable substitution. You might need a little while to scan over that to see, to reassure yourself that really that is the same as what I had previously in the other script. So React, so the 02 script produces the exact same output. And let's just prove that. 02. Yeah. So you can check that for yourselves. So we were able to nest create element invocations within create element invocations. Now, the way I'm implementing my React web page, I would describe it as taking an imperative programming style, which is the kind of programming that you have done mainly up to now. And with imperative programming, you know, your code consists of a sequence of steps that you want carried out, and those sequence of steps are carried out in a particular order, and their effect is to maybe change some state variables. That's imperative programming. An alternative style of programming is declarative programming, where you kind of describe the logic of what you want to have carried out, but the actual sequence of steps to execute that logic, that's taken care of by the runtime environment itself. Now, it turns out that when we do proper React implementation, we are going to be using a declarative programming style. As I said, what I've just shown you right now is an imperative programming style. That was best illustrated in the first script that I showed you. We had a sequence of steps and the code was executed in that order. Declarative is usually finishes up being a much more succinct way of coding. It takes a little bit of while maybe to wrap your head around it, but for now anyway, just be aware of the contrast between imperative and declarative. And that word declarative I will keep mentioning every now and again as we work our way through the React part of this module. Now, if we did have to write our React code in the way that I showed you there, as I said, it wouldn't be any fun, and the framework would never have caught on, because you would finish up with extremely long-winded code, very difficult to maintain, very difficult to understand. And so for that reason, the React team provide us with this JSX syntax. Although, as I said at the outset, it was really a third-party library that already existed, but they leveraged it. And what JSX allows us to do, as I'm saying in the header there of that slide, it allows us to actually implement our UI description in a declarative way. And this JSX syntax, as its name kind of suggests, you can mix it in with ordinary JavaScript. Now, it does have to be transpiled, though. You have to convert the JSX syntax. It has to be transpiled back into the type of coding that I've just shown you. But fortunately, the Babel tool, which we have already mentioned, that will do the transpilation for you in the background. So you write your code, your components, UI description using this JSX declarative syntax. Babel will transpile that into plain old imperative programming syntax, like what I've just shown you, and it'll all work fine. So our first example of what this JSX syntax looks like is in the 03 file, but I've purposefully called the 03 file error. I put error in its name because it ain't going to work. So let's look at the file first. And I want to achieve the same outcome, really. I want my header and a list of languages underneath it. And so here's my script. And effectively, you could say, well, that just looks like HTML to me, that you're assigning a piece of HTML, you're assigning it to a variable. And that's essentially what JSX is. JSX is 99% HTML. And so we're very familiar with HTML. And so that's really why it's easy for us to learn JSX syntax. Although we do notice there that, as I've already mentioned, if you want to associate a CSS class with a particular element, you've got to use the attribute class name rather than class. But other than that, this is essentially a piece of HTML. We're assigning it to a variable, and then we do our React DOM.render of that variable. So we've seen this already. We've seen this line already. This is new, but this has the same effect as the imperative code that I've just shown you. All of this is contained inside an HTML file. So if we try and render this, go back to here and bring up the 03. Nothing happens. Open up the developer tools. and we get an error, and the error is telling us essentially it doesn't recognize this symbol as being a valid JavaScript symbol. And what is it referring to? It is referring to this here. And of course, that is not valid JavaScript symbol in the context that I'm using it there. And so that goes back to my point that sorry, what did I do? Sorry, I highlighted the wrong one. Sorry, I beg your pardon. It's this one here is the one it doesn't like. And of course, it doesn't like it because it's not a valid JavaScript symbol. But as I said, this is JSX code, but this JSX code has to be transpiled back to the type of code that I've shown you earlier on. And I'm doing that in the 04 sample. So we're on to here. Now in my 04, I'm just referencing an external file, which I just thought was a little bit easier. So the file I'm referring to is this one here. And that can be found up in this folder. So it's the 04 sample I'm looking at. So I gave numbers to these just to help you relate one to the other. And you see I have two 04 files. And I've called them post-transpilation and pre-transpilation. The pre-transpilation contains the code that we had originally in our HTML file, but it didn't work. The post-transpilation is effectively the result of transpiling the code in the pre-transpilation one. That, and let me just leave it open. These two are related to each other. This is the kind of code, what you're looking at now is the code that you would write as a developer, but what is actually sent down to the browser is this stuff. And that transpilation is done, as I said, by Babel for you. You don't have to do it. Just pause for a second, maybe. Are there any questions? No? Okay. So, right. So we've seen JSX. It's a declarative style. All I'm showing you in this slide here is like how did I actually do the transpilation? Because I must have done it myself because I have two physical files. And really all I did was I used this Babel.js website that I mentioned to you there a couple of lectures back, which is, do I have it up? I don't, it doesn't matter. You may remember this Babel.js JS site, and what you do is you can paste in your JavaScript, your kind of ES6 plus JavaScript code on the left, and it'll transpile it to ES5 on the right. But in this case, now what you can also do is you can put in JSX syntax on the left, and it will convert it to plain old ES5 syntax on the right. You've just got to make sure that one of the options over here is to tick the React box. That's telling this website that what you will be pasting into the left-hand side is potentially going to contain JSX syntax. And that's really what I did. What I did was I took this code, pasted it in, and then took what it generated on the right-hand side and pasted that into this file. And this is the file that is being referred to from my HTML. I can't refer to this one because, again, we're going to be back with the same problem. So JSX is HTML-like markup language. Technically, it's actually XML, but as far as we're concerned, we can just regard it as HTML with a few extra little bits that are not standard HTML. And I've already mentioned the class and class name. I think that's probably the only one that you will come across throughout this module. So it is effectively HTML. And the benefit, as I already kind of alluded to, is it now allows us to write our UI description in a declarative style rather than using an imperative approach. So we get the best of kind of both worlds. The JSX has to be transpiled. We already know that Babel will do that for us. Now, how do we actually do it? Well, we could use that website that I just mentioned. We could use that and do a lot of cutting and pasting. There is also a command line tool that you can install, and you just point the command line tool at a JavaScript file that contains JSX, and it will create a transpiled version of that. But that's still very kind of low level and too cumbersome. A slightly better way from a developer's point of view is you can get web servers that have special instrumentation built into them. And the way these web servers work, so if you can imagine you're developing a React app where you've got lots of different components and you've got JSX scattered across multiple JavaScript files, then the web server, these specially instrumented web servers, they will just monitor any changes that you're making to your files, and it will transpile them automatically and send updates down to the browser. So you get that kind of live reloading as you're doing your React development. And we will see that a lot from next week on. But again, it's kind of sitting there in the background. You just start up the server and you forget about it. It does all the work behind the scenes. Eventually, you will want to deploy your React application, presumably to some cloud service. Now, we can't have this kind of monitoring and live retranspilation going on in the background when we deploy our React app to a cloud service. What we do in that case is we use a certain type of tool called a bundler tool. And what the bundler tool does is it essentially gobbles up all of your React JavaScript code, and it creates one output file, one JavaScript output file that has all of your components transpiled, and it ships that single file down to the cloud service that you're deploying your React app to. We'll actually use the bundler in the second of the two labs associated with this script or with this set of slides, but we may not actually use it after that. We'll mainly be using the instrumented development server, as we'll see. So I know I'm coming close to the end of the lecture now, but so we now know that when we are developing a React app, we develop components, but we actually haven't seen a component so far. All we've seen is this JSX syntax. So what is a component from a coding point of view? And it turns out it's actually going to be a simple JavaScript function. Now you can have any logic you want to in the JavaScript function, but critically, that function must return the JSX or UI description that it wants to have rendered on the web page. So it has to return a snippet of JSX. That snippet may be dynamically computed by the function or however, but it must return JSX syntax. And as we know now, the JSX is a declarative description of the user interface of a particular component, how we want it rendered on the screen within a web page. And when you do implement a component function, I suppose we'd call it, then you can actually refer to that component as if it was a new HTML element. You could think of components really as a way of extending the syntax of the HTML library of elements. So HTML comes with divs and h1s and paragraphs, etc., etc. Well, you can actually define your own type of elements. And these elements we would call components from a React point of view. But you can see here in the excerpt, like I want to attach something to the DOM. And I'm actually referring to my component, which is implemented as a function. I'm referring to it as if it was a type of HTML element. And that's permitted. So that's really, again, a nice kind of feature of React components. So it's a good place to wrap up, really. Finally, we can see a full React component implementation and have it rendered. And that's our 0.5 sample. So let's dig out that. Now we still have the transpilation issue. So I'm referring to a JavaScript file up here. And again, I have to have two forms of it. One is the one that I actually implement. The other one is the one that is created by the transpiler. So in this case, I've called them source and transpile. So source is what I write. Here's our first example of a React component. I've implemented it as a function, as I'm required to. I'm using the arrow function syntax. I could use any of the function syntaxes that I wanted to. In this case, the component doesn't really have any logic in it. Okay, if it did, you'd put it here, and it is returning some JSX, albeit 99% HTML. So that's my component. I've called the component that. And look at the very bottom of my file. I am doing react.render my component, and I'm expressing it as if it was a new HTML element. So that's the code that I write. That has to be transpiled. And we'll just quickly glance at the transpiled one, but we don't care about it because, you know, but not surprisingly, it's got react.createElement react.createElement all over the place. And so this is the file that my HTML is referring to, and it's really just rendering the same kind of UI as it turns out. Where's it gone to? Sample 5. Voila. So in summary for today, you implement components as JavaScript functions. Those functions return a snippet of JSX, and that JSX gets transpiled back to plain old react.createElement invocations, and you can attach a component to the DOM like this. Now, what we'll see later on, though, is that a component may have other components as its children, and those children may have children. And so when you attach one component to the DOM, because it has a whole hierarchy of siblings, you can effectively fill up the entire web page based on what those siblings produce.